Welcome back. I'm glad you could join us today. I thought today that we'd identify the different types of chemical equations. It really is an art form, if you think about it. So let's get into it, shall we? Let's start by having them run all the different types of equations that we're going to be learning today across the screen. I've got my standard 18 by 24 tightly drawn plain white canvas with me today, and that's some magical equations that are going to be on there. Okay, that's basically all. I'm going to take my big round stick and write the first type of equation that we're going to be learning today. Let's go right up here, right here. That's all there is to it. That's all there is to it. You'll see there are two reactants on this side, forming one happy product on this side. Think of it as having individual blue and individual red on this side, forming one pretty purple when combined. So you have your individual blue, your individual red, combining to get your single pretty purple. Okay, got that one finished. It's that easy. Decomposition is like that, but flipped. You have one single reactant that decomposes into two individual products. Here's an example. Back to our color analogy, that'd be like starting with our pretty purple and finishing with our red and our blue. There we are. Okay, now we've got our single replacement. For the products and reactants alike, we'll have one element and one compound on both sides. Something about like that. Now color-wise, let's say we have a yellow and a purple on this side, which is really just a compound of blue and red. On the other side, we would switch the yellow and the red, giving us this single individual red, and leaving us with the compound of blue and yellow, which is of course green. Beautiful colors. Although I do enjoy a good brown made from sap green and Alamazarin crimson. Man, if I could put some brown on here. Shut up. Shoot. Sometimes I get carried away. Okay. Alright. Let's move on, shall we? Then there's this next one. Double replacement or something like that. We'll have two compounds on this side and two compounds on this side. Different, of course. The elements in each compound are going to replace each other. It's a beautiful thing, really. We'll take our pink, a combination of red and white, plus this green, yellow and blue, of course, which will combine to replace each other into purple, which is, of course, a compound of red and blue, plus this light yellow color, which is yellow and white. Shoot, we're in business. Maybe a little bit more complicated. Don't worry about it. It's your life. Isn't that neat? It's gorgeous. Now we have an acid-base neutralization reaction. To identify this one, you're going to want to look on the product side for water, H2O, and a salt, something with a nice little sodium in it. Its reactants are always an acid, which has this nice little hydrogen in it, and a base. Here's a quick example for you. Artists such as I use salt to add texture to watercolor paintings. The of water and salt gives a little bit of a grainy look to the art. Now, let's get crazy. Our last is very exciting. It's called a combustion reaction. You'll be glad you joined us today. It's going to be a hydrocarbon. Take CH for example. That's going to burn with oxygen to create. Back up, we need backup, there's fire, back up. Oh dear. It's important to stay calm in situations like these. Everybody messes up, but you can still mess up if you have to. But anyway, your hydrocarbon and your oxygen are gonna burn to produce CO2, carbon dioxide, and water. I really hope you enjoyed this tutorial. It's a really simple little tutorial. It works. All of us at the station would love to see your progress as an honors chemistry student. Well, I would like to wish you happy identifying, and God bless you, my friend.